Every time that you went out, you always linked up with a friend of me. Girl, I saw you with the ops, you was not family, no kin to me. I swear that shit it.
Olá pessoal, boa noite. E a live tá meio tarde porque saí tarde do trabalho, como sempre. Bom, vou ver. Hoje eu ia fazer de manhã, mas não fiz. Então agora eu vou assistir algumas aulas de generics do YouTube, só pra assistir, ficar melhor. Oi amor, boa noite. Tudo bem sim? E você?
Hello there everybody. In this video I gotta cover generics in Java. Generics, it's a concept. It's where you can write a class, interface, or method, and it's compatible with different data types. There's two things we need, a type parameter and a type argument. So with type parameters, it's a set of angle brackets with a letter inside, for example, T. Basically this acts as a placeholder, and it gets replaced with the real type. Now on the other hand, type arguments, with various objects and data structures, you'll see a pair of angle brackets with a type inside, such as a string, but it really can be anything. It can be
É que eu tô falando com o microfone na minha mão, que como se eu te mandei a foto de como tá aqui o setup, e eu tô pegando ele na mão pra falar. Até que é legal.
Anything that uses this type parameter, it doesn't know the data type that it's going to receive. It's set up to receive really anything, or a primitive using a wrapper class. Let me give you an example of where you already see generics being used. For example, array lists. To create an array list, we add a set of angle brackets after array list. And we have to specify the type. What is this array list going to store? For example, strings. We would write the data type of string. Let's say that this array list is named fruits. Fruits equals new array list, and then we need a set of angle brackets again, parentheses, semicolon. In modern Java, within the second set of angle brackets, you don't necessarily need to type the data type again. Java can infer that, so you can leave it empty. This is the diamond operator. We have an array list that can store strings. We have specified the type argument, and now we can store some strings within our array list. So let's take our array list of fruits, call the add method, and add a few names of fruits, such as an apple. Let's do two more. Apple, orange, banana. Currently, the way that we set up this array list, it's compatible with strings, because that's what we set the type argument to be. Now, if I set this to be integers, well, we can't store strings anymore, but we could store numbers. 1, 2, 3. That's fine. Let me change that back. Generally speaking, an array list data structure can store all sorts of different data types.
Generics a tradução é genérico. Então é tudo que você faz no código pra deixar ele genérico. Pra tipo. Como pode dizer? Tipo criar um array. Ele pode armazenar. Um array list que pode armazenar vários tipos de dados, tá ligado? Tanto verdadeiro ou falso, que é boolean, tanto string, que é para lá, textos, né? Entre parênteses. Números, números com uma casa decimal, números com duas casas decimal, entendeu? Várias coisas. Então meio que tipo o T de type, de generic, ele vai se transformar em todas essas variáveis, ou todas essas variáveis, atributos. Todas as variáveis vão se tornar o T, que vai ser o genérico. Aí ele vai ficar assim. Foi o que eu entendi, entendeu? Posso ter falado abobrinha, mas foi o que eu entendi.
But when we create one, we have to specify what we're storing. That's the type argument. It's because within the ArrayList class, we have a type parameter set up, a set of angle brackets with a letter inside. In many cases, you'll see T meaning type for type parameter. So let's actually take a look at our ArrayList. I am going to locate ArrayList, jump to source. Here's the class for our ArrayList. There's a lot of advanced Java in here. Don't worry about that. But what I want you to pay attention to is the type parameter that comes after the ArrayList class name. We have angle brackets and a letter inside. In this case, E, meaning element, because an ArrayList has elements of data. By using this type parameter, our ArrayList is set up to store elements of various types. We just have to specify what the type is going to be when we actually do store data. And in my example, we're using strings. But like I said before, we can change the data type of what we're storing. We just have to change the type argument. I'll store booleans. True, false, true. I don't know what that has to do with fruits, but I'm just trying to prove a point here. So now what we're going to do is actually use type parameters. So let's delete our array list. Using generics, you can write some logic within a class, interface, or method, and it's compatible with many different data types. So what we're going to do in this example is create a class of box. Class box. We'll be using a type parameter to store all sorts of different things within our box. We can store a string within our box, an integer, a double, a boolean, even more complex objects. So we will set up a type parameter with a set of angle brackets, then type t. T is a common convention, meaning type. Let's say that when we create a box object, our box is going to act as a container. We'll store a value inside. Our box is going to be a reusable class. We won't always know what the data type of what we're storing is going to be. So what we could do is set the data type to be t. Let's say that this variable is an item. We're storing an item within a box. With t, it does mean type, but I like to think of it as thing. We're storing a thing, an item, within our box. We don't know what this thing is going to be. But really, it means type, and that's not as fun. T, item. We don't know what the data type is. If it's always going to be a string, we could just set this to be a string. But what if somebody is storing an integer, an int? Or we can use the wrapper class of integer. We don't know what the type is going to be. Let's create a method where we will set our item. Let's say that this is public, void, it's not going to return anything, set item. We'll have one parameter. What's the data type of what we're receiving? Well, we don't know, so we're going to use our type parameter of t. T is the data type. It's generic. We will receive an item. Let's take this dot item and set it to be the item that we receive. We'll create a method to get our item. Public. Now we're going to be returning an item. The data type is t, so the return type is also going to be t. We're returning a value of the t data type. We will create a method to get item. We will return this dot item. We can put things in our box, and we can get things from our box. Alright, this class is done. Our box class is set up to be reusable. We can store all sorts of different things, so to say, within our box. We will attempt to create a box object. For now, let's say box equals new box. But there's one step that we're missing. We have a warning here. Raw use of parameterized class box. We need to set up a type argument. What are we going to be putting in our box? What's its data type? Our box class wants to know. So we will use a type argument. After the class of box, add a set of angle brackets, then type what we're going to store. So let's say we're going to store strings within our box. Values of the string data type. And then we do need the diamond operator after the second box. And we're good. We now have a box object. But it's set up to store strings. Let's add some items to our box. We've even created a few methods for this. Set item. Let's take our box, call set item, but we have to pass in a string. let's add a banana to our box. And then we will get the banana from the box using the getItem method. And now I want to get the banana. Box.getItem. Here we go. We have our banana. We have successfully retrieved the banana from the box. Our box class is compatible with all sorts of different data types. This time, let's store an integer. We will use the wrapper class of integer, but we can no longer add a banana to the box, because it's a string. I'll attempt to do so. String cannot be converted to integer.
Quando ele colocou ali integer, que é
Fortunately,
inteiro,
bananas are
tem que
not
ser
numbers,
número. Então
but I can
o
add the
string que é
number 3 to our box.
a banana, a palavra banana,
We have the
ela deu
number
erro,
3
você viu?
within our box.
Ficou um
If I
negocinho
attempt to add a
vermelho
double,
embaixo.
like 3.14, we get a warning. Incompatible types. Double cannot be converted to integer. So I would have to set the type argument to be double, to add doubles to our box. 3.14. Basically, with our box class, we're writing the logic of how a box works. You put something in, and you can take something out, and it's compatible with different data types. We just have to use a type argument when creating a box object. We have to let Java know what we're storing within it exactly. Alright, let me give you another example. Now with type parameters, you can have more than one type. We can have 2 or more different types. Usually the common convention is to use U after T. So we're going to create a new class. File, new, Java class. We will create a class of product. Here we're going to write the logic of how a product works. With a product, you have an item and you have a price. We will set up a type parameter. Let me zoom in. We'll have one type of T, and a common convention for the second type is U, because in the English alphabet, the letter U comes after T. If you had a third argument, that would be V by common convention. So we'll just stick with T and U. We will have a generic type of item, and another generic type of price. We don't know if our item is going to be a string or a more complex object. Our price could be an integer, a floating point number, a double. We don't know, but that's why we're setting it up this way. Now we'll need a constructor. We will take our product, then set up some parameters. The data type of our item is T. T item. But if we're creating a product, we also need a price. The data type of our price is U. U price. This dot item equals the item that we receive. This dot price equals the price that we receive. Okay, let's do a test run. Let's go to our main Java file. Product equals new product. And again, we need those type arguments. So this time we actually need 2, because our class is set up to receive 2 type arguments, T and U. For our product, let's say that the first type is going to be a string, followed by a double. And then we need the diamond operator after the second product. Alright, now we have to pass in arguments to the class. Because we have a constructor, we have to pass in an item and its price. And with our type arguments, we set that up to be a string and a double. We have to pass in those types. For our product, let's say that it's an apple, and an apple is 50 cents. That's a double. Let's create 2 methods within our product class. We will create a method to get our item. Let's say public, we're returning an item. The data type is T, so we're going to return T. Get item. We will return this dot item. Then to return the price, let's say public U, because we're returning the price. It has a type of U. Get price. Return this dot price. We have our product object. I'm going to output, take our product object, call the get item method. And this is going to return our apple. Or I could get the price. Get price. And that is 0.5. You can use string format, but that might be overkill for this lesson. Alright, let's create a second product. So we'll have product 1 and product 2. Now product 2 will use an integer instead of a double. And let's say that these are tickets, like movie tickets. Ticket, and the price will be 15 for $15. Let's take product 2, call the get item method. So we have our ticket, and we should have a price. Get price. The price of a movie ticket is $15. Alright everybody, so that is an introduction to generics. It's a concept where you can write a class, interface, or method that is compatible with different data types. Basically, we're writing the logic of how this class works, and it's compatible with all different types. You just have to set up a type parameter, and then pass in type arguments. And well everybody, that is an introduction to generics in Java.
In this video, we're going to talk all about generics in Java. Generics can be super confusing the first time you see them with all the T's and question marks and angle brackets and K's and V's. But I promise by the end of this video, you'll know exactly what generics are, why they exist and why they're useful, and how you can use them in your own programs. My name's John, I'm a lead Java software engineer, and I love sharing what I've learned with you in a clear and understandable way. I also have a full Java course available in a link down in the description if you're interested. First, to have a good understanding of what generics do and why they exist, it helps to know the kinds of problems that Java developers were running into before generics existed. Let's say I wanted to create a class where all it would do is hold an integer value that I give it and then print out that integer whenever I wanted to. So we might call something like that integer printer. You can go ahead and click finish and create that. So this class would be pretty simple. We would have an integer field for the thing that we want to print. So we can call it thing to print. And we can have a constructor for this class that takes in this thing to print. So that would be public integer printer. Then it takes in an integer for the thing to print. And that would just set this dot thing to print equal to the thing to print that was passed in. And we can have one method to actually print this out whenever we want to. So that would be public void print. And all that does is just print out the thing to print to the console. So system.out.println thing to print. So if we wanted to use this integer printer class, we would just create an integer printer equals new integer printer and pass in the integer that we want to print here in the constructor. So let's say we want to print out the number 23. Now, of course, we can call printer.print, and when we run our program, of course, it prints out 23. But what if we wanted to do exactly the same thing for a double instead of an integer? Well, we couldn't use this class, right? Because it only holds an integer. It doesn't hold a double. So what can we do? Well, basically what we have to do is make a copy of this entire class, and we can call it double printer. And then inside that double printer, we would basically have all of the exact same code, except instead of integer, we would have double. So this new class will work great for holding and printing doubles. But what if we now want a class that'll do exactly the same thing but work for strings? Well, of course, you have to do the exact same thing again. You have to copy that class, make a new class called string printer, and change all these doubles to strings if you want your class to be able to print strings. So now we have three completely separate versions of essentially the same kind of class. And you can start to see the problem. We would need a whole other class if we wanted to do this with floats or dogs or cats or cars or trucks or whatever type of object that we wanted to print. So we'd end up with a ton of code duplication, and this is with a really simple class. If you had a more complicated class, the code duplication would be even worse. Well, that is where generics come in. Generics offer you the ability to have one class like this that is flexible for many, many different types. So let's go back to our original integer printer and make it generic. So first, instead of calling it integer printer, let's just call it printer because it should be able to print anything. Now, when you want to use generics in a class like this in Java, right here after the class name in the declaration, but before the curly braces, you have to define what is called a type parameter, and you'll put your type parameter in angle brackets like this. By convention in Java, typically you'll see this type parameter just called t, but technically you can call this type parameter whatever you want. But I'm going to just be using t so you can kind of get used to seeing it, because that's the convention that you'll see elsewhere. You can think of it as standing for type. In this class, what this t represents is the type of thing that this printer is going to be able to hold and print. So instead of just having an integer field here, it's going to be of type t. Right now, as we're coding this class, we don't know what types of things this printer is going to be asked to print. But this gives the ability to create printers for any types that you want. So of course, we also have to change the name of our constructor to just printer to match the class name. And that constructor also, instead of taking in an integer, is going to take in something of type t. So now this class is a generic printer for whatever type we want. But now how do we actually use this class if we want to, for example, create an integer printer like we had before? Well, back here in our main method, instead of an integer printer, now of course we're going to just create a printer. But now you can see that we have a warning here that printer is a raw type, and references to generic type printer should be parameterized. It wants to know the type of thing that we want to be able to print. And in this example, we want to be able to print integers. So how we specify that is in angle brackets here, after printer, we type in integer. That tells Java, I want a printer for integers. And we have a similar warning here. To get rid of that, you just need to put in angle brackets after the class name printer. In older versions of Java, you used to have to put the type in there again, but you don't have to do that anymore. This integer here that we're passing in the angle brackets is what's going to be used as this t type in this printer object that we are creating. So now we can run our program as we did before, and it still prints out 23. But now what's cool is we can go in and get rid of those two extra classes that we made, the double printer and the string printer. We can just delete those, because now we can use our generic printer class to be able to create printers for doubles and strings also. So now all we have to do, if we want to create a printer for doubles, we just say printer and pass in double or t, the type that we want this printer to be able to print. We can call it double printer equals new printer, and give it a value like 33.5. And we can call double printer.print. And of course it prints out 33.5. So now we've created one printer class that can print any type that we give it. Doubles, ints, longs, floats, pigs, monkeys, cars, trucks, whatever. One thing to note though is that generics don't work with primitive types like lowercase int and lowercase long. But all you have to do is just use the wrapper classes like integer, and everything should just work the same way. One place that you've probably already used generics all the time is with Java's collections framework. For example, if you wanted to create an array list, you've probably done this, where you've specified in angle brackets the type of thing that you want to have in your list. So if you want to create an array list of cats, you say array list cat. We'll call it cats equals new array list. This gives you an array list that you can only add cats to. So you can say cats.add new cat. And that works fine, but if you try to do cats.add and pass in a new dog instead, you get an error because we specified that cat was the type of thing that this list was going to hold. And if we try to give it a dog, we get an error. In the same way, up here where we created a printer for doubles, if we try to pass in a string, like, hey there, we get a similar error because we told Java that this was going to be a printer for doubles, and here we're trying to give it a string. But you might be thinking, well, hey, John, if we want to be able to create a list of anything we want, why do we have to deal with all these generics? Why can't we just create like an array of just objects and then we can put whatever we want in it? Well, it is true that you can do that and your code will work, but it won't be type safe at all. And let me show you what I mean. Let's say that our array list, instead of holding cats, just holds objects. This is the kind of thing you'd have to do if generics didn't exist. You'd just have to create an array list that can hold whatever. So in this imaginary world without generics, we still want to create a list of cats. So we've added our new cat to our list. But let's say sometime later on in the code, we want to be able to get stuff off our list and use it. So if we want to get this first cat off the list and put it in a variable, we would want to create a cat, call it my cat, equals cats.get the first element of the list at index 0. But here we get an error that we have a type mismatch. You can't convert from object to cat. Java doesn't know that this is supposed to be a list of cat. It just knows it's a list of objects. And so we have to tell Java, yes, I know this is a cat, so you can go ahead and cast it to a cat so I can store it in this variable. But what if instead of adding a cat to the list, somebody adds a dog? Well, the code all looks the same. There's no compilation errors or anything. But of course, if you try to run it, you're going to get a class cast exception right here on this line, because you're trying to cast this element in the list as a cat, but it's actually a dog. So just having an array list that can hold whatever type of object causes all types of these type safety issues. And generics solves that problem for us. So now we can say, yes, I want to create a list of cats. So then in the code, if somebody tries to add a dog to that list, they get an error and it won't even compile. And also, since Java knows that this is a list that can only contain cats, whenever you get a thing off of that list, it is 100% guaranteed to be a cat, and you don't have to do any special casting. That's how generics help us. They offer the ability to create classes that can accommodate tons of different types, but also the structure and the type safety of knowing exactly which type you're using that class with at the moment. But there are even more cool advanced things that you can do with generics. Let's go back to our generic printer class. So right now we can create a printer of whatever class that we want to, right? But what if instead of being a printer for any type, we want this to be a more specialized printer for animals? For example, I have this cat class here that extends the animal class, and I also have a dog class here that extends the animal class. So if we want this to just be a printer for any type of animal, instead of just saying T, we can say T extends animal. Now back here in our main method, we now get an error when we try to create a printer for integers or doubles, because now this printer only works for animals. So we can create a cat printer, and in the constructor we can pass in a new cat. Or we can create a printer for a dog and pass in a new dog. But what's cool about that is now in our printer class, since we know that whatever is passed in as this type extends animal, any method that is defined in the animal class is available to us in our thing to print variable, because we know that this thing to print, this T, is going to be some type of an animal. So now because we know this thing to print is an animal, down here in our print method we can call thing to print dot eat, because this eat method is available in the animal class. So if we didn't have this extends animal, if we just took in any type at all, we can't call the eat method because this T type isn't guaranteed to be an animal at all. So there's no way to know whether it will have an eat method available on it or not. When you do this type of thing, it's called a bounded generic, because you're giving a certain bound, a limit, on the type that's able to be passed in. You can also use bounds with interfaces. Let's say you wanted to guarantee that this type implemented the serializable interface. You just put in extends serializable. You might think that because this is an interface, you should put implements here instead of extends, but no, it's just not the proper syntax. It still has to be extends, even though it's a little bit weird. Another cool thing you can do is have multiple bounds. Let's say you wanted to make sure that it was a subclass of animal and also implemented the serializable interface. To do that, you can just say extends animal and serializable here with an ampersand. And you can list as many things as you want here, all separated by ampersands. There's just a couple restrictions. You can only have one class, which makes sense because Java doesn't support multiple inheritance. And you always have to list the class name first with any interfaces after that. If you try to switch it around and put the interface first, you'll get an error. In addition to having generic classes, you can also have generic methods. Let's say we wanted to make a method that can take in any type of object and print it out with exclamation points. Private static void, let's call it shout since it'll print things out with exclamation points. It'll take in some kind of type that we're going to call T. We'll call it thing to shout. And inside that method, all we're going to do is print out that thing to shout with a bunch of exclamation points after it. So right now we're getting an error here because Java is saying, hey, T isn't a type. What do you want me to do with this? To tell Java that this T is supposed to be a generic type, right here in the method signature, right before the return type, you put that generic type in angle brackets. Again, you can call this whatever as long as it matches here and in the parameters, but by convention, you're still just going to see t most of the time. So now here in our main method, we can call our shout method with whatever we want. You can send in a string like John, you can send in an int 57, or you can even send in a cat. So this can take in any type of parameter that we want to send, and when we run it, it'll print them out with exclamation points. Java also supports the ability to have multiple different generic types here. So in addition to taking in this t thing to shout, we can also take in, say, v other thing to shout. All we have to do is add this v to our angle brackets here and separate them with a comma. And now this method will take in 2 of any sort of type. So we can pass in John and 74 and also go ahead and print out other thing to shout. And that works and is now flexible with any 2 types at all. If you want, you can also have multiple generic types like this in your generic classes. So over here in our printer class, if we wanted to have another field here, let's call it v other thing. And all we have to do is specify that up here in our angle brackets as well, separated by a comma. If you happen to want to return one of these generic values that are being passed into your generic methods, all you have to do is specify that return type as the return type here. So instead of void, if you want to return something of type t, you just put t here as the return type. And then in here, of course, you just have to return something of type t, which can just be this thing to shout. The other advanced generics topic I want to talk about is wildcards. Let's talk about a situation where you might want to use a wildcard, and then we'll show how you can do it. Let's say we wanted to be able to create a method that can take in a list that holds any type of objects, and we want to be able to print out that list. So we might call that print list. So how do we specify in the parameters here that we want to be able to take in a list that contains any type of thing? You might think that we can just say, okay, I want to take in a list of objects. And we can call it my list, and all it will do is just print out that list to the console. So now up here, we can create a list of integers, call it int list equals new array list. And we can take our int list and add the number 3. And then we can try and call our print list method with our int list as the parameter. But if we try and do that, we get an error here that says we can't pass in this list of integers as this parameter that's supposed to be a list of objects. But it might feel like you should be able to do that, right? Of course, an integer is a subclass of object, so shouldn't we be able to pass in just a list of integers? Well, even though integer is a subclass of object, a list of integers is not a subclass of a list of objects. So this doesn't work. This is where a wildcard will work to solve your problem. So instead of saying that this is a list of objects, we say that this is going to be a list of unknown by passing in a question mark. This question mark is the wildcard. You use a wildcard, a question mark, as the type parameter when you're using a generic when you don't know what exactly that generic type is going to be. So it's saying, hey Java, I've got this method here and I want it to be able to take in a list of anything, but I don't know what it's going to be a list of. So now you can call this method with a list of whatever you want. In this case, we're doing it with a list of integers, but you can also do it with a list of anything else. Let's say we had a list of cats. Add a new cat to that list, change this to cat list here, and pass the cat list into our print list method, and it now works with lists of both types with no errors. You can also have bounded wildcards similarly to how we did in our generic class. So instead of being a list of anything at all, we can say this has to be a list of something that extends the animal class. Now you can see up here that we're getting an error when we're trying to call this method with a list of integers, and that's because integer doesn't extend animal. We don't get that same error here when we're calling it with a list of cats, because cat does extend animal. If you enjoyed this video or learned something, please let me know by leaving a like, and be sure to subscribe so you don't miss each new Java tutorial. And of course, don't stop now. Keep learning by watching one of the other videos below. Thank you so much for watching. I really appreciate you being here with me. I'll see you next time.
Só para não passar pro dia 26 não passar batido, que eu realmente não consegui estudar hoje. Até a próxima live. Falou, pessoal. Pra quem tá na live.